Having seen date times and time series, let's now extract time series properties through other manipulations. Recall our data frame of sales data from February 2015. The data frame contains sales events distributed unevenly throughout that month. Using a process called resampling, we can apply statistical methods, for instance mean, sum, and count, computed over different time intervals. Now let's see how to resample a time series and compute related statistics. In the context of resampling, downsampling means reindexing a time series with equally spaced times of lower frequency, like going from daily to weekly. Upsampling then is the opposite, like going from daily to hourly. Here, we'll use resample to get daily averages of sales in February. Explicitly, we use sales.resampleD.mean. There are three important things to notice here. First, the method resample needs a string to specify frequency. Here, D stands for daily. Second, the resample method is chained with the mean method. It is best practice to follow resample with some statistical method in this way. Third, the result is a data frame with daily frequency for February 2015 with the average number of units sold each day. The columns company and product are non-numerical and hence are ignored. Missing days are filled with NaN, but that can be changed. Let's check the daily mean result for February 2nd. The .loc accessor tells us the mean on that day is 6. We can similarly slice the original sales data frame along the units column for that day to see the two sales made. When we apply the mean method to that slice, sure enough, the result is 6 again. Remember, when using resample, we use method chaining. In this case, we chain resample with the sum method to get daily totals. Method chaining is often used with pandas methods that return data frame or series objects. In the exercises, you'll practice method chaining with resample and also with the rolling method. We can build long chains of methods if we want. Here, we determine the daily totals using resampleD.sum. We chain the max method after that to tell the highest total units sold in any day of February 2015. The maximum number of units sold in any single day was 29. Resample combines with many of the statistical aggregation functions, for instance count, var, and std. Let's count the number of separate sales made each week in February. We resample with W to indicate weekly periods. Then we chain on the count method. The result has 3 columns because the count method applies for strings also. The week ending February 8th had the most individual sales. Here's a table of the most common strings used as arguments to resample. The strings correspond to different sampling intervals. In fact, we can use integer multiples of these intervals with resample as well. For instance, the sum of unit sales over 2-week intervals is computed using resample to W. Since we're only interested in how many units were sold, we've selected the units column before calling .resample. Notice the first entry is February 8. This is the same value as the first row when using W. By default, the 2W offset is aligned by Sundays, and February 8th was the second Sunday of the month in 2015. Up to now, we've been downsampling. Downsampling uses a coarser time index with fewer samples. For instance, downsampling a statistic from daily to weekly data. The opposite is upsampling, making a finer time index with more samples. For instance, upsampling from daily to hourly data. As an example, let's fill in the blanks for units sold every 4 hours on February 4th and February 5th. We use the .loc accessor to select the time range from February 4th to February 5th inclusive. This gives 4 rows with times unevenly distributed over those 2 days. We can use resample with the for_h input argument to sample every 4 hours. Chaining the ffill method fills in the number of sales using the forward fill method that you have already seen. The technical term for this is interpolation. Of course, we can use bfill or other methods. The resulting index represents the starting time of each 4-hour increment. Now it's your turn to do some exercises with method chaining and resampling of time series. To finish up our discussion of time series, let's look at some new plotting techniques with pandas. Here we'll learn line types, plot types, and subplotting. We'll use daily data from the S&P 500 Stock Exchange in a data frame indexed by date from 2010 through 2015. Here are the first 5 rows. The columns are the opening, closing, high, low, and adjusted closing prices, along with the volumes of trades daily. As we've seen, using the data frame .plot method with a date-time index automatically formats the horizontal axis to use year, month, date labels. This is the resulting plot. The label on the x-axis is copied from the index column automatically. We need to add the y-axis label and a title by ourselves. The title is added using the option title in the plot method, and the label is added using matplotlibs.ylabel function. This is the labeled plot. You can see here that only the years 2011 through 2015 are shown on the x-axis. The formatting of the x-axis labels adjusts to display relevant information depending on the range of date times in the index. For example, here's a plot of the S&P 500 closing price selected using the .log accessor for a very short range, the first week of April 2012. In selecting and plotting a shorter time span, the day appears at each x-axis tick. The year and month appear only at the bottom left corner of the plot. By default, pandas.plot uses a blue line. To modify the default behavior, we can use the keyword argument style to pass a MATLAB-like style string. The preceding format string also results in a line plot of the close price with a black line with a dot. The style format string consists of 3 characters. The first character is the color. K here refers to black. The second character specifies the marker, a dot in this case. The final character controls the line style. Here, a hyphen means a solid line. Here's a small table of other style combinations. Recall, Pandas plot method also takes an argument kind for other types of plots, like bar charts, box plots, area plots, and histograms. For instance, using kind equals area here plots the closing price at the end of each month, first by resampling the data. We also know we can plot multiple columns at once. Pandas will draw multiple lines and plot them with different colors and add a legend. Here we plot the close price and the volume together for 2012. As we saw before, there's a problem with this plot. The volume is so much larger than the price that we cannot see the latter at this length scale. Rather than using a logarithmic scale, let's make separate plots for the close price and volume. Pandas lets us do that within a single figure with the subplots equals true argument. This makes a separate plot with separate y-axis limits for each column. By using subplots equals true, we can now directly compare associations between the volume of trades and the closing price. Do some exercises now to try your hand at plotting time series.